Hi, I'm Ryan, and you're watching my YouTube series on functional programming. In this episode, I'm going to talk about the data last principle of defining a function's arguments. This is a very simple principle, and all it says is when you're defining the order of your function's arguments, the ones that are known the most should appear on the left, and the ones that are known the least should appear on the right. It's a very simple principle, and you would notice this in the design of a lot of functions that are used in a functional context. So let's see some examples and understand why this principle is useful. So I'm going to start by showing you a very simple function which only takes one argument, which is the print. It only takes one argument and prints its value. So if I were to uncomment this line and iterate on the array and just try to print it, it's going to print these values. So this principle is not relevant when you have only one argument, right? Because you need multiple arguments to decide which is known and which is unknown. So let's see another example over here. We have the sum function, a curried sum function, not a regular sum function, because it takes two arguments in the form of curried functions. So x and y, and eventually returns x plus y. And what this lets us do is it lets us define another function like this, a sum1, where the first argument is already known beforehand, right? So I made this new sum1 function, and now I can loop on the items array, or I can map on it and say sum1 dot map print. And if I run this code, you would notice that the sum1 function was waiting for the second unknown argument, and when it received that from the items array, it was able to map on it, and eventually we mapped on it and printed these values. So this is another simple example of a known and unknown argument. However, I feel that this is not very real world because it's unusual for you to define a function like this, and x and y seem to have an equal weightage. So let's see another example where it is very clear when arguments are known and unknown. So I'm going to clear this, I'm going to comment this out. So in my third example, I'm going to show you a get.json function. So we have a bunch of IDs, right? And let's say these are the IDs of a user. And we have a get.json function which you can get from any library. And usually what arguments it takes is like a path and the payload that you want to pass to it, right? And as a developer, at the time of writing, you usually know what is the URL you want to access. So let's say these are user IDs. So I have a user endpoint point is equal to /users, right? And generally you would call get.json with get.json with user endpoint, and what you want to do is you want to pass, let's say, user of 1, say IDs of 1, and then 0 and IDs of 1, right? And that's how you get to the return value of the AJAX request. But notice that this is something that we are doing on an iterative basis. So we are repeating this code, right? So this is a very good example where you can actually see that we have one known argument and the second argument is unknown. The weightage is very clear over here. So we're going to change this a little bit. And instead of this get.json being a simple function, we are going to make it a curried function. So everything is the same. I have a curried version of get.json now. But the first argument of path is a known argument. And what this lets me do is I can create a function called as where getUser is equal to get.json with user endpoint. So now I have this nice helper function where the first argument is already filled in for me. So now I can simply iterate on my user array, get user, and I can map it to something else. If this is an async operation, so you cannot map it directly, but you get the idea. You could always return promises and then loop on that and resolve them when they print values when they're resolved. But the point I'm trying to make here is, by knowing that the first argument is going to be available to us long before we invoke this function, we can create a bunch of helper functions and then we can map over them in the future. So this adds a lot of value to uh, to creating creating your application such that you have a lot of utility functions, and your program only has to provide the last argument to actually invoke it. And well, that's about it for this video, for this episode, and I hope you find this useful. And if you do, please like, comment, and let me know if you have any questions in the comments. Thanks for watching.